My friend Erin goes to the Philippines to visit her relatives. Every time she would bring back a bit of golden rice, which was very common in her area. A couple years ago, I had the pleasure of having lunch with her soon after her arrival, and her parents made me adobo, which was marinated rice and was accompanied by this golden rice. Adobo was marinated meat, which was accompanied by golden rice. At the time, I thought that this golden rice was just plain white rice that had been cooked to give a golden hue. However, it was genetically modified to be more substantial and healthy. Now I would like to shift your attention to Farmer Elena. Farmer Elena lives in a rural village, and every day she wakes up to go to her golden rice fields to tend with hope and passion. You see, many years ago, Farmer Elena's village suffered from frequent illness from their poor immune system, and their children were not able to play as joyfully because they didn't have proper eyesight from lack of vitamin A and other proteins. However, after Professor Ingo Patricus and Peter Baer developed golden rice by inserting genes from daffodil and other bacteria, they were able to create rice that had enough vitamin A and proteins so that Elena's village's children could play with ease. In this informative, I will talk about the history of genetic engineering, what are some common methods it is used, and lastly, the impact. To start, genetic engineering was first started by Herbert Boyer and Stanley Cohen, who created the first genetically modified organisms. These were used for research, and these people are often known as the fathers of genetic engineering as they started the practice of it. Later, when we advanced to the 1980s, genetic engineering started taking place in agriculture. We already had an example with the golden rice before, but the most popular item that was genetically modified was the Flavor Saver tomato. The Flavor Saver tomato was a genetically modified tomato so that it was bigger, juicier, and it stayed ripe for longer. This helped the stores because they could allow their produce to stay on the shelves for a longer time without getting rotted or decaying. Next, in 1982 and the 1990s, scientists and researchers developed synthetic insulin. Before, insulin was very hard to come by. It was much rarer than it is nowadays. However, after it being artificially produced, it became more accessible to the people who were struggling from many problems. Along with this, another important part that happened in this time was personalized medicine. Around the world, there are millions of people who are suffering from genetic disorders and other diseases, and they can't get the proper treatment because their body will not allow different types of treatment, therapies, or medicine. So allowing genetically modified, personalized medicine, people were allowed to get the proper treatment they needed to cure their disease. Next, this is probably the most crucial development in genetic engineering, it is the CRISPR-Cas9. It is a gene editing tool that uses genome editing, which we will talk about later, to help with genetic disorders. One of the most popular ones is the Vertex Pharmaceuticals. It uses the sickle cell disease, which are located in the bone marrows, to help create healthier hemoglobin. With the sickle cell disease, the hemoglobin in people, which carries oxygen from the lungs to people's tissues, would be decayed. With this disease, if Farmer Elena were to get it, she would be tired all the time, she would have shortness of breath, and she wouldn't feel good overall. However, with the Vertex pharmaceutical, scientists and researchers can change people's hemoglobin so that Elena and other people don't have to go through what they already did. These show the main points that genetic engineering has gone through, and it has much more potential. Essentially, genetic engineering is the manipulation of genes to help create a better and improved organism, says Peter Baer. So now we will talk about the different ways genetic engineering is used in. So we've already stated that the first one it was used in was through genetically modified organisms. These were used in research to help develop model organisms to help with research in developing good habitats, finding vaccines for different animals and humans, and creating more medicine. Next, it was used in agriculture. We already saw it was used in golden rice and the flavor saver tomato and many others. And then it was also used in medicine with the synthetic insulin, as well as the personalized medicine and the CRISPR-Cas9. So now we will talk about the different methods genetic engineering uses to improve organisms. We will talk about gene splicing, molecular cloning, and genome editing. First, however, we will talk about how genetic engineering really comes to be. Mel Robbins once said, what you want exists, so don't settle until you get it. This is often used in genetic engineering because many engineers find that there's something that has a problem, but they want to improve it. So they won't stop until it becomes the best it can be. We can use it for the example with farmer Elena and her golden rice. In the beginning, there was just plain white rice. And this is what Professor Ingo Patricus and Peter Bear understood. They realized that this white rice, which many people were consuming on a daily basis, lacked something. It lacked the vitamin A and the proteins that were essential in the human body. Together, they did research and they found out that daffodil and other bacteria had the same vitamin A and proteins that this white rice could essentially need. So together they combined the daffodil and bacteria with the white rice to create golden rice. This is used in many different practices, but now we will look at the different types. So gene splicing and molecular cloning are very similar to each other. Gene splicing is like cutting and gluing part of a DNA to a different organism so that it improves. On the other hand, molecular cloning is taking a piece of a DNA and inserting it into another organism, which is usually bacteria, so that it can, over time, duplicate and produce more of the same bacteria that was originally put in. So the main difference between these two methods is that this one only has one type, this one will only contain that one strand, while this one will have millions of the DNA strands that scientists can later take out and put into new organisms to improve. Lastly, the genome editing is the most common used method of genetic engineering, and it is similar to writing a book in English. In English, when we're writing a book or an essay, we go through many processes and steps. We'll start off with brainstorming, then we'll do a rough draft, and we'll revise and edit before we get our final product. It's the same in genome editing, except we've already have our brainstorming and final rough draft done. We are given the rough draft, which is usually an organism that is lacking something or needs something else to become better and improve. So researchers look at its DNA and they see what they can do to improve it. So researchers will create a new DNA strand by switching out, deleting, or cutting these old pieces and create new ones. The CRISPR-Cas9 uses the genome editing tool and is frequently used by many researchers nowadays. Now we will talk about the impact of genetic engineering. In medicine, it has helped a lot. It has making synthetic insulin and personalized medicine allows it to become more accessible to the people who are having problems so that they can get the proper treatment they need. In agriculture, we can see that there are more produce and foods that are being more available to us so that we can have a healthier meal diet and be a healthier person overall. And in research, scientists and engineers use genetic engineering to allow them to create new vaccines and new medicines which will help us in the future. All in all, it is quite evident that genetic engineering has come from a long way. just from starting with the genetically modified organisms to the CRISPR-Cas9, it is quite clear that genetic engineering has a lot of potential. Thank you.